There's something strange hiding behind everything you can see, touch, or measure. Something that even quantum physics, our most accurate description of the universe, still can't fully grasp. Think about it. Quantum theory can predict the behavior of particles with a precision so perfect it's almost supernatural. It can explain how atoms bond, how stars shine, how your smartphone works. But ask it why a particle chooses one reality over another, and it goes silent. We've built an entire civilization on equations that work, yet describe a world we can't truly imagine. Beneath every atom, every flash of light, every neural spark in your brain, lies a domain that behaves like a dream pretending to be solid. Quantum physics opened that door a century ago, but what's behind it remains blurred, almost deliberately hidden. Some scientists believe we're only seeing one thin slice of a much deeper structure, a reality made of invisible layers stacked like dimensions of information. Others whisper that consciousness itself might be the missing variable, the part of the equation physics refuse to include. And maybe, just maybe, the universe isn't made of matter at all, but of something stranger, meaning, probability, or even code. If the equations are right but our understanding is wrong, what does that say about everything we call real? What if quantum physics is not the final truth, but the first clue that reality has layers we're still blind to? To understand what might be hidden, we need to start with what we think we already know. Quantum mechanics tells us that everything, electrons, photons, even space itself, behaves not like solid objects but like waves of probability. A particle doesn't have a single position until you measure it. Instead, it exists in a vast cloud of possibilities. Observation collapses that cloud into a single outcome, but no one knows how that collapse happens or why. For decades, physicists treated this as a practical mystery. Shut up and calculate, they said. The math worked, so who cares what it means? But that attitude built a strange kind of blindness into science itself, because if we can't explain why measurement creates reality, then maybe we don't actually know what reality is. Take the double-slit experiment, the oldest magic trick in physics. Fire one electron at a wall with two slits, and it creates an interference pattern, like a wave passing through both slits at once. But observe which slit it goes through, and suddenly it behaves like a particle, choosing one path. The universe changes its behavior depending on whether we're watching. Some physicists think this means reality is participatory, that observation doesn't just reveal the world, it helps build it. Others argue that hidden variables, perhaps buried in unseen dimensions, secretly determine outcomes before we ever look. But here's the riddle. Every attempt to find those hidden variables has failed. Bell's theorem proved that if such variables exist, they must break one of our deepest intuitions, either locality, things only affect nearby things, or realism, things exist with definite properties whether we look or not. Experiments have repeatedly shown nature breaks something, and yet something still feels missing, because quantum theory doesn't describe the stage where all this happens, the canvas that allows probabilities to even exist. What is space itself made of? What is the wave function made of? No one knows. That's the silent boundary of modern physics, the place where equations stop and questions begin. Maybe there's a deeper order beneath the quantum layer, a sub-quantum realm where information, geometry, or consciousness shapes what we later call particles. Or maybe we're asking the wrong question entirely. Because if the hidden layer isn't below reality, what if it's above it? And we're the ones inside the equation. Everything we've ever believed about the real world begins with one assumption, that things exist independently of us, that the moon is still there when we're not looking, that your room doesn't vanish the moment you walk out. But quantum physics quietly dismantles that comfort. If the act of observation truly changes what exists, then reality isn't just out there. It's relational. It happens between the observer and the observed, a kind of cosmic handshake where both sides define each other in the moment. That's not philosophy. It's what the math actually says. But our brains were built for stability, not uncertainty. We evolved to track predators, not probabilities. So we force the universe into a story we can live with. Objects exist. Time flows forward. Causes create effects. Yet each of those statements collapses under the quantum microscope. Time, for example. In quantum theory, the equations work perfectly well backward. Causes can, in principle, flow both ways. There's even evidence, faint but haunting, that particles might know future conditions when deciding how to behave now. Retrocausality, it's called. It makes no sense, and yet the math welcomes it. Then there's entanglement, Einstein's spooky action at a distance. Two particles born together remain linked, no matter how far apart they drift. Measure one, and the other knows instantly. Not fast, instantly. Across galaxies, across time. That's not communication, it's unity. It means separation might be an illusion created by limited perspective. And what about space itself? Quantum field theory treats it not as emptiness, but as an ocean of vibrating energy. A restless foam birthing virtual particles that appear and vanish constantly. What we call nothing might be the densest something imaginable. So maybe we've been thinking of reality upside down. Maybe particles, forces, and even space-time aren't the foundations. Maybe they're the surface. A holographic projection of deeper rules we haven't glimpsed yet. It's like looking at a 2D shadow and trying to imagine the 3D object casting it. Our physics describes the shadow perfectly, but not the source of the light. That's what the hidden layers could be. Not smaller pieces of matter, but entirely new levels of description. Patterns of information, entangled geometries, or rules that sit beyond space and time themselves. If that's true, then every experiment we run might just be measuring the echo of something invisible, something that doesn't even exist inside our universe. And here's where it gets truly unsettling. What if the reason quantum physics can't explain those layers is because we are one of them? To explore what could lie beneath or beyond quantum physics, we need to look at the evidence that something deeper might be whispering through the noise. Let's climb this ladder carefully. 4 steps, each one stranger than the last. Step 1. Quantum gravity's missing link. General relativity explains gravity through the curvature of space-time, while quantum mechanics describes everything else through probabilities. Both work flawlessly in their own realms, but they refuse to merge. Every attempt to quantize gravity explodes into infinities. That breakdown is our first hint that quantum theory isn't the bottom. It's a layer itself, resting on something that can unite geometry and uncertainty. Maybe that something isn't made of particles at all, but of information woven into the very fabric of existence. Step 2. The holographic principle. Black hole physics gave us an impossible clue. According to Hawking's calculations, black holes radiate information, yet nothing can escape their gravity. So where does that information go? The answer shocked physicists. It's encoded on the surface of the black hole, not inside. This led to the bold idea that our entire universe might work the same way, a 3D reality projected from a 2D boundary of information. If true, everything we experience, every atom, thought, and galaxy, is just a holographic unfolding of data stored at the universe's edge. Step 3. Quantum entanglement and space-time. Recent studies at Caltech and Harvard are showing that entanglement itself might build space-time, not as a metaphor, literally. The geometry of the universe could emerge from the pattern of connections between quantum bits of information. Space might not be a container, but a relationship. That means distance is just the strength of information links. Change those links, and you might tear or bend reality itself. Step 4. The observer problem revisited. Experiments in quantum cognition, quantum biology, and even quantum computing have started revealing something wild. That observation might not require a conscious mind, but an interaction that transfers information. Reality happens wherever information becomes irreversible. But then, what defines irreversibility? Time, entropy, or something even deeper? A self-reflective loop, like consciousness itself observing its own structure. Every one of these clues points toward a disturbing conclusion. The quantum world might not be fundamental. It might be a shadow of a more intricate network of informational or conscious architecture, a kind of meta-reality we can sense but not yet describe. Physicists are beginning to whisper about this new layer, the post-quantum domain, where information itself could be more real than matter. But if that's true, what happens when information starts observing us back? If information is more fundamental than matter, then physics isn't describing objects anymore. It's describing relationships. The universe becomes less like a machine and more like a mind. That's not poetic exaggeration. It's where the logic leads. A universe where the act of measurement shapes outcomes, where entanglement defines space, and where information drives existence. That's not a mechanical world. That's a participatory cosmos. The implications are staggering. If reality emerges from information, then consciousness, and the ability to experience and interpret, isn't an accident. It's a feature of the system, perhaps even its engine. Philosophers like Bernardo Kastrup argue that what we call the physical world is actually a shared dream within a universal consciousness. Quantum mechanics, he says, is what physics looks like when that dream is analyzed from the inside. Meanwhile, physicists like John Wheeler, decades before anyone else, proposed that the universe might be self-excited. In his words, the universe does not exist out there, independent of us. It is brought into being by acts of observation. But critics push back hard. Many physicists insist that bringing consciousness into the equation is an unnecessary metaphysical leap. They argue that quantum mechanics is complete. Weird, yes, but not mystical. According to them, our confusion stems from using human language to describe something that's fundamentally mathematical. The universe doesn't need observers. It just needs interactions. And yet, there's a gap that refuses to close. Why is there an interaction at all? Why do probabilities become facts? Why do equations that describe waves of possibility suddenly result in a single, undeniable now? Even the strongest defenders of the traditional view admit that quantum mechanics doesn't explain the transition from potential to actual. It predicts it, but doesn't illuminate it. That missing explanation sits at the heart of every interpretation, from the many worlds hypothesis to objective collapse models to theories where the universe itself is a vast quantum computation. Each of these ideas points to something beneath or beyond the quantum layer, something that might give rise to the probabilistic behavior we observe. And here's the philosophical tremor. If such a hidden layer exists, then our universe might not be a self-contained reality at all. It could be an interface, a perceptual surface between us and something far deeper. We may not be discovering the truth about the universe. We may be discovering the rules of a translation. But if reality is just an interface, what exactly is it hiding behind it? If the quantum world is only one layer, the next frontier isn't just about building bigger colliders or faster computers. It's about building instruments that can peer beyond the quantum veil itself. Physicists have already started sketching what that might look like. The field is called post-quantum physics, and its goal is audacious: to find what the wave function is made of, to understand the reality beneath probability. One of the first roads leads through quantum information science. As quantum computers evolve, we're beginning to test the universe itself as a computational system. Every qubit manipulation, every entanglement experiment is not just technology. It's an interrogation of reality's code. If space-time truly emerges from information, then quantum processors might one day simulate the structure of reality itself, not a representation, a recreation. Then there's quantum gravity, still the holy grail. String theory once promised an elegant unification, but newer ideas are shifting the focus. Physicists like Eric Verlinde propose that gravity itself might be an emergent phenomenon, not a fundamental force, but the result of quantum information arranging itself in patterns that create the illusion of curvature and attraction. If that's true, then gravity isn't pulling on you right now. The universe is reorganizing information around you to keep the illusion of space consistent. Meanwhile, new technologies are pushing the limits of observation. Quantum sensors, atomic interferometers, and entangled detectors are reaching sensitivities once thought impossible. These tools may soon detect deviations, microscopic flickers, that suggest another layer of dynamics beneath quantum behavior, a hidden field, a subquantum ocean. But the biggest shift might come not from machines, but from minds. Some researchers believe consciousness itself could be a window into this deeper reality. Not in a mystical sense, but informationally. If consciousness is the universe becoming self-aware through biological instruments, then studying it could reveal the rules by which reality encodes experience. It could mean our inner worlds are the first contact point with the hidden layer, not a metaphor, but a mechanism. The convergence of neuroscience, quantum computation, and cosmology may create a new kind of science, one that doesn't just observe reality, but participates in its formation. A science of the interface between being and existence itself. But there's a risk, because if we begin to probe the structure that makes observation possible, what happens when we start observing that? If the universe only exists through interaction, what happens when we stare directly into the code that defines it? It's easy to think of all this, hidden layers, entanglement, post-quantum realms, as something abstract, detached from daily life. But what if it isn't? What if every decision you make, every breath, every flicker of awareness is already part of that deeper fabric? One you've simply never noticed because you've been looking through it your entire life. When you remember something, when you imagine, When you love, you're doing something extraordinary. You're transforming information into reality inside your own mind. Neurons exchange quantum signals, microtubules resonate, electric potentials collapse into patterns that you call you. The same laws that guide subatomic particles are playing out inside the theater of your consciousness. You are, in every measurable sense, a quantum process trying to understand itself. Maybe that's why the universe feels so mysterious, because it's not an object to be solved. It's an experience unfolding within us. The idea of hidden layers isn't just about physics, it's about perception. The layer beneath quantum mechanics might mirror the layer beneath your thoughts, the unconscious architectures of awareness that generate your sense of self. Both may be holograms projected from something deeper, something not yet grasped. And here's where the connection gets personal. If reality is participatory, then your choices, attention, and even beliefs might influence the version of the world you inhabit. Not through magic, through interaction. The act of awareness could subtly tune the probabilities of what becomes real. That idea isn't pseudoscience, it's the philosophical implication of quantum measurement itself. Observation matters, and every human being is an observer. That means you are not a spectator in this universe, but you're a co-creator. So the next time you look up at the stars, consider this. Those photons left their galaxies millions of years ago, traveling through quantum fluctuations, gravitational distortions, and cosmic expansion, all to end their journey in your eyes. The act of seeing completes their story. You close the loop. Maybe that's what these hidden layers are really about. Not cold, unreachable realms of physics, but the subtle truth that consciousness and cosmos are entangled. The mystery isn't out there. It's woven into the act of being here. And if that's true, then discovering the hidden layers of reality isn't about finding another theory. It's about remembering that reality itself might be waiting for you to wake up and see it. Maybe reality isn't something we'll ever pin down with absolute certainty, because it's not meant to be pinned. It's alive, fluid, responsive. Quantum physics gave us a glimpse behind the curtain, but what we saw wasn't the machinery of a clockwork universe. It was a living equation that changes when looked at, a cosmos aware of being watched. The deeper we go, the more we realize the limits of measurement, the boundaries of logic, the shimmering edge where knowledge dissolves into wonder. Those aren't failures of science, they're invitations. Perhaps the hidden layers of reality aren't out there at all, waiting to be discovered like new continents. Maybe they're layers of participation, levels of awareness that awaken only when we do. You and I right now are part of that awakening. Every thought, every moment of attention ripples through a field of possibility so vast it humbles even the equations that describe it. Imagine if the universe isn't a cold expanse of particles, but a dialogue between matter and mind, between observation and existence, between what is seen and what chooses to be seen. The hidden layers of reality might not be secrets to uncover, but mirrors reminding us that the ultimate mystery has been within us all along. And maybe that's the real lesson quantum physics has been whispering for a century. The more we understand the universe, the more the universe seems to be understanding us. Do you believe these hidden layers of reality truly exist? Or are they just the limits of our imagination? Tell me below. Your view might change someone's mind.